All right, for the primary keys part of the chapter 5, I'm going to PowerPoint at you a little bit, and we're going to talk through some examples, talk through some of the important concepts. So let's go ahead and work through this, and I will try to remember to post this PowerPoint up in case somebody's interested in looking at this. So we're going to talk about the importance of the primary key because it is so important to the design of your database that you have to put a whole lot of thought into selecting primary keys. And the main thing you have to remember when selecting a primary key is that it has to uniquely identify each row in your table. So each student has to be uniquely identified. Each book has to be uniquely identified. Each camper activity has to be uniquely identified. And so what you have to think of is you have to think of all of the circumstances that exist in the business that might cause that primary key to be duplicated, and you need to avoid it. So you cannot have any circumstances when a primary key can be repeated. So let's just look at an example here where we're trying to decide what to have as our student primary key. So the first thing we might say is let's choose the last name. So in my case, my last name is Schultz, and so that would uniquely identify me until Joan Schultz shows up. And now you can no longer identify each record in the database based on the last name Schultz because there are 2 or 10 of us. And so you might look at a composite key. You might say, okay, there are a couple of fields I can string together that will uniquely identify that person. So let's put the first name and last name together. So in my case, it's Leah Schultz, which is not a very common name. And you're thinking to yourself, well, that'll probably get away with that. But you have to think of all of the circumstances. Are there going to be more than one Leah Schultzes? Maybe. Probably not. If the answer is maybe, then you stop right there. It's not a primary key. But you can also think of other examples of data that would probably cause problems. There's going to be more Joe Smiths than or John Smiths or John Robinsons. So real common names are going to cause that problem. So again, you think to yourself, well, I'll make it even less likely to be repeated. So let's add middle name. So now Leah Schultz is uncommon, but Leah Ann Schultz is probably even more uncommon. And so, but still, there is a chance. And then again, we can go even further and add birth date. But again, it's very unlikely that somebody with my full name, with my exact birth date, will enroll at Tarleton. But the problem is, if that possibility exists, then you have a database design problem, because the minute that Leah Ann Schultz, who was also born on 8/6/71, tries to enroll in Tarleton, that primary key is taken. New Leah Ann Schultz can't sign up for classes, and now you have to go through a big design. And you could keep adding things like mother's maiden name and phone number, and you would eventually get down to where the possibility of all of those things being the same is so super unlikely. But how far do you have to go? How many fields do you have to add? And again, why take a chance if you don't have to? So it has to uniquely identify each entity in a table. And each table has to have a primary key. So even those join tables, those bridge tables that we are working with to resolve our many-to-many relationships, they have to have a primary key to uniquely identify that interaction. So let's look at our camper issue from Lab 1. There's nothing to uniquely identify a camper, just like there was nothing to uniquely identify me as a student. We could use SSN. So that's one thing you start to think about when you start working with people is, hey, can I use their social security number? We might have that access to that. We probably also don't want to expose that to everybody who has access to our database for privacy and identity theft issues. Also, think about other things that are going to cause that to be a problem. Let's say that we do have access to their social security numbers and we don't really give a hindquarters about privacy, and we decide to go with social security number. But then our camp is so well known that we have visitors or campers coming from all over the world, most of whom don't even have a social security number. They have their own country's uniquely identifying number, or they might not. Back when I was younger, when I was a kid, you didn't get your social security number until you were a lot older. Now they're assigned much earlier, but there are international campers who wouldn't have a value to fill into the primary key. So if you make one up, then you run into the trouble of what if you accidentally duplicate a real ID and now you don't have a unique identifier. So you make one up. In this case, I made up a field named camper ID. We'll talk about this. This is called a surrogate key, and we'll talk about those in just a minute. I'm a big fan of surrogate keys. But we just make one up, and we have the computer actually just increment it as part of its functionality. So when camper 1 shows up, their camper ID is 00001. The next person signs up 00002, and the database can never repeat that. And so we always have a unique identifier. So here's a look at the camper table, or a glimpse of what could be in the camper table. So you'd have the camper ID assigned as the primary key, the first name, last name, birth date. And then in this case, I have bunkhouse assignment, which is a foreign key, but it matches the primary key of the bunk that each camper is assigned to. So if we were to go look at a bunk table, there would be uniquely numbered bunks that would tie back to the camper table through this relationship. So let's talk about the primary key of our bridge table. So again, here's our camper activity enrollment. We don't have a camper ID, or we don't have a primary key yet. This table consists of the camper ID, the activity ID that they're going to enroll in, and the progress report. So this is where a counselor can say, ooh, Jimmy's doing really well at pottery, or whatever. So what uniquely identifies this? Stop and think of what this table is showing us. One camper enrolling in one activity. That's a one-to-one relationship. The camper can't enroll in the same activity twice, because that's not how our camp works. So what we can do is we can do a composite key. And so you would have the camper ID and the activity ID together, uniquely identifying this one entry into the table. It'll never be repeated. And I say that assuming that we dump our activity assignments at the end of each year, because Jimmy could come back next year and take horseback riding again. And if he has the same camper ID and the same activity IDs are from the previous years, we could have repeats. So we have to be careful about that. Again, thinking of all the possibilities that can make our primary key not uniquely identify that row in the table. So let's look at composite keys for students enrolling. This is an enrollment table. So many students can take many classes, or student can enroll in many classes, and classes will have many students. So we have a many-to-many relationship. We're going to put a table in between those to join those and break those down to one-to-manys. And so we have the student who's enrolled, their ID. We have the course ID that they're enrolled in. We have the semester that they're enrolled in, the year, and then the grade that it's going to be or has been assigned. So let's look at this composite key. Student ID obviously is not going to work, because a student ID is going to show up in this table for every class they enroll in. So that's not a good primary key by itself. So the student enrolling in a course, well, that sounds like a good idea. But again, you have to stop and think about what happens in the real world. If a student enrolls in a course ID and then drops that course, well, they have to take it next semester. And so their student ID will be entered with that course ID again, thus violating your composite primary key of student ID and course ID. So you add semester. Now the student can enroll in one course in the fall of 1989 or whatever year. And so in this case, to uniquely identify when a student takes a class and allows them to repeat the class if they fail or if they drop it, we actually need 4 separate fields to uniquely identify that a student enrolled in a course in the fall semester of 2019. Now, the grade itself is just extra information that's tied to this individual existence of this record. But we do need 4 fields to create a composite key that is unique to the student enrollment situation. That's what I just said. So let's talk the last little bit I have on composite keys. So the other thing you have to think about is when you use a composite key, it has to do with the relationships between the entities. So in the real world, if these two things are strongly connected, you probably would consider using a composite key. So an example of that is a dependent is not going to exist in an employment database if their parent doesn't exist in that database. So it's fairly common in a strong relationship like that that you would see a composite key of the child on the child. And then in the database itself, does the way you've set up the database or the way you've represented the data relationships in your database, does it create a strong relationship? And we'll talk a lot about this a lot, but in a sales database, you'll see an order. A customer makes an order, and on that order, there are going to be many items that are going to be line items. Now, a line item is not a thing that exists in the real world, but because this is the way we've conceptualized our data, it's unlikely that a line item could exist without an order that it's tied to. So in cases like that, you'll see more common uses of composite keys. The last thing is, I'm not a big fan of composite keys. The database programming that I've done through my career usually has depended on what we'll look at in a minute of surrogate keys. But the one other reason you want to think about your composite keys is when your composite key gets too unwieldy, when it gets too long, when it includes too many fields, you might want to think about dumping it and using what's called a surrogate key. A made-up key really is what it's going to be. And the reason I say that is because your database doesn't exist just out in the real world, just sitting there being a database. People are writing SQL commands. People are writing programs against it. When you type a search command into Amazon, there's a program behind the scenes that says, go into Amazon's databases, go into this table, find this keyword, and it goes about its business that way. So when you have programmers who are writing code against your database and they're trying to join their tables together, or they're trying to select data from a table, the more complex the composite key is, the more they have to type that every single time into their code, the more likely they are to make mistakes. It wastes time if there's additional typing for no reason. So if your composite key starts to get really long, I highly recommend that you change over to a surrogate key. So what are surrogate keys? They're made up. They stand in for a real key. A lot of times items just don't have a real natural key. There's no part number, no social security number, no VIN number, nothing like that. And so what you do is you just have the database create a made up key. You could use it again if you chose not to use something like social security. You could use a surrogate key to protect your data as well. They can be used to simplify complex composite keys. So our course ID, student ID, semester, and year could be whittled down to student course ID as a made-up number. And there's no meaning tied to these keys. The number that is used has no strong tie or even a relationship to the entity that it's representing. It's just a number that's been assigned to it. And the good thing is databases are built in to automatically assign numbers. And so you don't have to do anything. You tell the database when a new entry is made into this table, automatically generate a number that is going to be the primary key. And the great thing about that is the database knows not to repeat itself. And so you would never have a primary key repeat that the database generated itself. So think of your student ID at Tarleton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or 0. That doesn't have anything to do with you. I can't look at your ID and I can't know what county you came from, or if you're male or female, or if you're in the top of the class, or if you got a 1200 on your SAT. I can't tell anything about you from your student ID. The only thing I can vaguely tell is maybe how long ago you started at Tarleton, just because every time a new student signs up, the database adds one, next person signs up, database adds another number. So the lower your number is, the longer you've been at Tarleton. But that's really all you can tell, because at a basic level, that number has no meaning except for the fact that it was assigned to represent you. So like I said, I'm not a big fan of composite keys. I use surrogate keys a lot of times. That's why I messed up on the solution file. If you saw my announcement yesterday, or well, that doesn't make sense. You don't know when your last module. I assigned a surrogate key in one and didn't have a foreign key as the surrogate key. But a lot of this just depends on style. A lot of times your company will have requirements of or programming handbooks that'll tell you how to handle some of these things. But a lot of that you'll just learn when you get your job. You just need to understand what it is. So let's practice a couple of examples before we end up. Let's choose primary keys. And I'm going to talk to you through some of the choices you might make and why ultimately you might or might not choose that. So let's look at a customer of Verizon. The first thing that you think about is, aha, every customer's phone number is different. We all can't have the same phone numbers. It's not like the 1960s when we have party lines. There is one phone number assigned to me. There might be more than one phone number, but there is one primary phone number that they could select. Excuse me. And it's not a bad thought, but a lot of it depends on the business rules of the database. So only one person can have a phone number at a time. So it's looking pretty good. However, you have to ask yourself, does Verizon keep track of older numbers? In other words, if my number is 254-123-4567, when I give up that number for some reason, do they automatically delete my record that's tied to it, or do they keep that historical data and then reassign the number to another customer at a later time? If they do that, if they keep historical data as well as current customer data, and we both have the same phone number, then that's obviously not going to be a good primary key. And in most situations in service industries where people have customer numbers, again, most of the time that's a surrogate key that has been assigned by the database. Okay. All right, here's one from our B quiz, the single car in a car rental company. So quite a few people put that they would put the make or the model as the primary key. And this is a big no. If you said Ford was going to uniquely identify an item, that means you could only have one Ford, because the next time you tried to buy a Ford and enter Ford in as the primary key, the database would say, no, you can't do that. You might do something like a Ford Explorer. Again, if you try to uniquely identify all of your inventory just by that way, you can only have one Ford Explorer. The next time you try to enter Ford Explorer, and when you buy your second one, it's going to not let you add it. So neither of those would do a very good job of uniquely identifying your inventory. So another option would be license plates. And to be honest with you, I don't know a whole lot about license plates and how numbers are assigned and how they're kept historically. So somebody who's designing this database would probably work with the car company who would know more about this, but it's a possibility. Within Texas, license plates are unique currently, but historically, is that true? Or is it possible that a car from the Hertz rental car in California could have the same license number as a Hertz rental car in Texas, and just because they don't repeat in-state doesn't mean they don't repeat between states? And so that starts to get a little bit messy. It would make me really nervous as a database designer. So you might think through that. And then you go, aha, the VIN, the vehicle identification number, which is assigned when cars are manufactured. It's a beautiful thing. The only reason the VIN exists is to uniquely identify cars. So if your car gets stolen, you can tell the cop, my VIN number is blah, 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 blah. And when they find your car stripped and it doesn't look anything like your car, that VIN number is still there, and they can tell you that your car has been totaled. So that's really what it's for. It looks pretty good. And in most databases, this would suffice, but you have to take it one step further. You have to know what the company is trying to accomplish. Because let's say that I actually have a rental car company that also rents muscle cars from the 60s. You can get a 1965 convertible Mustang as your weekend rental to drive down the coast. And in that case, you have a problem, because older cars that are still in existence were made before the VIN number came around. And in this case, you might have items in your inventory that don't have a VIN number on them. If you try to create one, you run the risk of using an actual VIN in existence and can cause problems. But again, If you don't have that type of car in your inventory, you don't have to worry about it. You use the VIN and you go about your happy way. If you have different business circumstances, then you have to accommodate those in your database design and assign a surrogate. All right, so the last one I want to look at is the orders and the order invoice line. We're gonna look at this in so many different ways and so many different examples in the textbook, because this is a very common structure in a database. A customer places many orders. Each order will have many items on it, and those things can be repeated as needed, and that breaks down the many-to-many relationships that exist. So the customer. There's no way to really identify a customer. Again, you usually assign a surrogate key to just a number for the customer account. So the order is nothing really intrinsically different about one order over another. So there's nothing that naturally identifies a number. So you assign an order number. You have the computer assign the order number as your key. So then let's look at the line item on the order. It's going to be a bridge table. It'll have the order number and the product number. So this is that middleman that ties back to the main order that was placed on March 2nd. And you can tie that back to the customer through that relationship. And then you can tie it forward to the products in your product database. So there's no way to uniquely identify this. I can order 3 things today, like 3 notebooks today, which would be a line item on today's order. And I could order the same 3 notebooks next week, which would be a line item on the next order. So they're exactly the same a product ID, but they would end up on a different order ID. So the only thing that would be different would be the primary key. You could have a composite key, and that's very common, the order ID with the product ID. That makes an assumption that you have to handle that through a quantity field. If I add 3 notebooks as single entries, then I'm going to repeat that combo of order ID, product ID. I'd have it on there 3 times, which would not work as a composite key because you can't repeat your primary keys. So again, what you'll see a lot of times if you don't use a product key is in that table there will be another primary key field generated by the database. Nobody ever sees that number, but it allows the database to internally keep control of what are unique items in that table. So that's all I have right now for primary keys. I hope this helped you work through some of the concepts, but also hopes you just gave you some more practice about thinking of these things. Each business situation is going to be unique, and the best thing I can tell you at this point in your understanding of database is, when in doubt, if you really can't think of all of the instances where a primary key might repeat, go ahead and work with a surrogate key and let the database take care of that for you to ensure that you have integrity in your entities. So we'll move on to chapter 6 next, and that's the end.